Hello students, welcome back to our Jee Prep channel. Hope all of you are doing well. Today we will solve one problem on vertical circular motion. Let's read the problem. A stone tied to a string of length L is whirled in a vertical circle with the other end of the string at the center. At a certain instant of time, the stone is at its lowest position, means this position, and has a speed u. The magnitude of change in velocity as it reaches a position where the string is horizontal is under root x in bracket u square minus gl. The value of x is, and these are the four options given to us. Now students, see there is one string and one end of the stone is tied to the one end of the string and the other end of the string is being held up. So this is the initial position of the string. This is the rigid support. The stone is held up at this position and this initial velocity is u, that has been mentioned here. This is the initial velocity u. Now because it is exactly horizontal velocity, so this is u I cap if you write in a vector form. So this A is the initial position. Now what has been done? The string is made exactly horizontal. So stone will be here. So this is the final position of the string. So the velocity vector here is in this direction. The velocity vector is in this direction. Now we want to calculate the change in velocity. Of course, they have given certain expression for the change in velocity. That expression consists x and we need to find out that x. Now how to work out this problem? The methodology is this. Now as a stone is initially at point A and then finally it goes at point B. So the total energy of the stone remains constant. In vertical circular motion, total energy remains constant. But the initial kinetic energy will be different from the final kinetic energy, while initial potential energy will be different from the final potential energy. So what we'll have to do? We will have to equate the total energy at point A and the total energy at point B. But for this, we need to find out the potential energy at point A, kinetic energy at point A, same way potential energy at point B and the kinetic energy at point B. So the potential energy here is 0 while kinetic energy is half mu square because initial velocity is u. Now here potential energy will become mgl while kinetic energy is half mv square, where v is the final velocity. Then its velocity vector will be v j cap because it is exactly vertical vector. So therefore the total energy at point A is equal to total energy at point B. Hence, the total energy at point A is half, kinetic energy is half mu square plus potential energy is 0 is equal to total energy at point B is kinetic energy is half mv square plus potential energy is mgl. Let us simplify this. You will get u square is equal to v square plus 2gl. How? The m will be cancelled here and then we'll have to multiply throughout by 2. So we will get this equation. Hence, v square is equal to u square minus 2gl. So the final velocity vector v is equal to under root u square minus 2gl. Now, what is the initial velocity? V initial is equal to u into I cap, while final velocity vector is v into j cap, which is under root u square minus 2gl into j cap. So then what will be the change in velocity? Actually we want to find out the change in velocity. So the change in velocity is delta v is equal to final velocity minus initial velocity. Final velocity minus initial velocity, and this comes out to be, what is the final velocity? Under root u square minus 2gl into j cap minus u into I cap. So therefore delta v vector is finally under root u square minus 2gl into j cap minus u into I cap. Now we want to find out the magnitude, because what they have mentioned here, the magnitude of change in its velocity. So the magnitude of this vector will be, magnitude of this velocity vector will be under root the coefficient of vector j cap the whole square under root u square minus 2gl the whole square plus coefficient of I is minus u the whole square. So this will be now under root, this will be u square minus 2gl plus u square. So this will be under root 2u square minus 2gl. So I will take change in velocity vector is under root 2 into u square minus gl, u square minus gl. Now, but they had given the value of the magnitude of change in velocity is under root x into u square minus gl, but it is given that delta v, magnitude of delta v is equal to under root x into u square minus gl, hence the value of x must be 2. The value of x must be 2. Now let's see which is the correct option. So B is the correct option. I hope all of you understood this problem. And student, if you really want to perform very well in the JEE examination or MSCT examination, I strongly recommend all of you to subscribe our channel. Thank you.